Okay, greetings. This is still the Unit 6 exam review, and on this part I'm going to kind of tackle a few of the problems that are partial fractions. So this one is going to be a partial fractions problem. You know that because you see something that you can factor in the denominator, so that's a clue that partial fractions is a good strategy. And so we're going to rewrite it as the sum of two fractions each with the factored parts, okay? So we write it like that. And then what we're basically saying is if this is equal to this, if the integral of this is equal to the integral of this, then these two pieces must be equal. So we're saying 1 over the x plus 1, x minus 1 equals a over x plus 1 plus b over x minus 1. And now we're going to get a common denominator so that we can add those fractions together. So over here you'd say, oh, well, this needs an x minus 1 over x minus 1, right? That undercover 1. This side needs an x plus 1 over x plus 1. And then you'll say, all right, now we have a common denominator. So remember, when you have a common denominator, you can kind of get rid of those denominators. Technically, what you're doing is cross-multiplying and then dividing the common denominator out, okay? But you'd end up with 1 equals a times x minus 1 plus b times x plus 1. And then we want to basically get each of those to zero out. So we would say two parts that we're interested in. We say at x equals 1, what would happen? And at x equals negative 1, what would happen? So if you were to plug in x equals 1, this piece zeroes out. So you'd have 1 equals 0 plus 2b. And, of course, that would lead us to b equaling 1/2. And then over here, if you plugged in x equals negative 1, this piece, the b part, would zero out. So you'd have 1 equals, if I plugged in a negative 2, there would be a negative 2a plus 0, and that would lead us to a being negative 1/2. Oop, 1/2 there. Okay. Now, remember, these are very frequently just the opposites of each other, but in no means is that always the case. So it's not uncommon for that to happen, though. All right. So what I do now is I take this a and this b, and I take them and I plug them back in for a and b over here, and then I use my property of integrals that says that the integral of this is going to be equivalent to the integral of the first piece plus the integral of the second place. So I'm going to kind of break that up. So I'm going to say something, maybe I'll switch and I'll say, so, right? So I'm kind of rewriting this in a way that I can work with it. So I'm going to say that that equals, okay, the integral, and we'll say of a, so that was negative 1/2 over x plus 1 dx plus the integral of positive 1/2 over x minus 1 dx. Oops, I'm writing right off the paper. Sorry about that. Now I can kind of factor out these 1/2s and the negative 1/2 there, and I can kind of do the calculus part. So I'm going to take out a negative 1/2 here, so I'm integrating 1 over x plus 1 dx plus, and if I factor out this 1/2, and then I'm integrating 1 over x minus 1 dx. Remember, when you're integrating 1 over the junk, you can say that it's ln of absolute value of the junk as long as the derivative of that junk is a 1. If the derivative of this, if that denominator is not 1, then you would have to do a u substitution. So I can go ahead and I'm going to say this is negative 1/2 ln the absolute value of x plus 1, and then plus 1/2 ln absolute value of x minus 1, and a plus c. Okay, so that would be a safe stop, but very frequently we see that they usually write these condensed as a single logarithm, or they'll use some of these exponent rules, right? So here, since these are actually attached by subtraction, you can almost think about it, this is the same thing as this 1/2 ln of the absolute value of x minus 1 minus 1/2 of the ln here. So you can combine them and rewrite them kind of even just factoring out that 1/2 even, or kind of rearranging these. Okay, maybe I'll just say that's going to be ln. And remember that 1/2 becomes the power. So 1/2 is going to become the power on both of them. If they were separate, you can kind of keep them separate, but it'll be the absolute value. And I'm going to put the square root over the whole thing since they're both going to be raised to the 1/2 power. But this divided by, because it's this one minus that one, so it's this one divided by that one, using those exponent rules and those log rules, plus c. That would be probably what it would look like on a multiple choice. Okay, moving right along. I don't know if this integral got messed up on your favorite. That's supposed to be the integral of, the full thing. I don't know, that got a little messed up. Sorry about that. Okay, so if I was doing this one again, my goal here is to kind of rewrite this as the integral of some a over the first factor, which that can factor into an x minus 2. Ooh, that looks sloppy, sorry. Okay, plus some b over x plus 1 dx. Okay, so once I have that, then we're going to say, all right, we set those two things equal to each other. So we say the 4x plus 1 over, and I'm just going to factor it out, equals a over the x plus 2 plus b over x plus 1. Get a common denominator so that then we can kind of get rid of it. So we're going to say an x plus 1 over x plus 1 and an x plus 2. Oop, wait, that's supposed to be minus 2, so they're supposed to be minus 2s. Minus 2, not a plus 2 there. Okay, so we got that. So we cross multiply. Technically, that's just kind of eliminating that denominator. So you end up with 4x plus 1 equals a times the quantity x plus 1 plus b times the quantity x minus 2. Sorry, it got a little sloppy there, but it's a minus 2. All right, so now is the part where we kind of evaluated a specific thing. So I'm going to say, if I had one wish for x, I might want x to be negative 1, or I'm interested where x would be 2. So I plug each of those in and then solve, right? So if I plug in a negative 1, you're going to get negative 4 plus 1. Well, negative 4 plus 1 is negative 3 equals. If I plug in a negative 1 there, it zeroes that out, so you'd have a 0, and that'd be a negative 3b, right? Negative 3b. So that means that b equals 1. Okay. And then over here, if I plugged in a 2, 2 times 4, it's 8 plus 1 is 9. So I'd get 9 equals 3a plus, and if I plugged it in there, that piece zeroes out. So we've got that, and then that would mean that a equals 3. So where in the last example, see how they were kind of opposites? Here they're not. And again, that happens sometimes and sometimes it doesn't. So now I can go ahead and rewrite this. So in other words, this thing, right? So this thing is equal, okay, that original thing, really I'm saying, so that original is equal to, and I'm going to kind of pull it out, I'm running out of space here. So I know it's going to be the integral of 3 over, right? But I'm going to go ahead and factor that out right away to save myself a little bit of room. So it's a, I'm going to pull out that 3, 1 over x minus 2 dx, plus, I don't need to factor out the b because it was a 1, right? So it'll be plus the integral of 1 over x plus 1 dx. So there's my setup. And again, when I'm integrating 1 over the junk, as long as the derivative of that junk is a 1, it's just ln. So the 3 comes down. So this is equivalent. So I've got 3 ln of the absolute value of that. And then it's plus the ln of the absolute value of this plus c. We have an indefinite integral here. So there is going to be that plus c. Okay, so then we're going to use our log properties to condense as a single logarithm. So a couple of things I'll do in this step. I'm going to take this 3, right, and it's going to become the exponent, okay? And then I'm going to say that you can rewrite it as a single logarithm. With logs, a plus sign, that means they're going to be attached by multiplication. So this is going to be mathematically equivalent to ln, the absolute value of x minus 2 raised to the third power, right? That's the power property of logs, multiplied by x plus 1, and then the plus c out there, okay? So notice in the previous example, see how there was a negative? So I thought of it as this minus the ln there, so the minus changes to division, but here they were both positive, so in logs, when they're related with a positive, we can say it's multiplied, okay? All right, and there is one more example I'm going to do, and I'm still on the review, and I'm going to switch to page 3. There is a definite integral using partial fractions, so I'm going to do that one. So again, you have that partial fractions look because you see that there's kind of factors in that denominator. So we're going to go ahead and rewrite it as the integral from 3 to 7 of a, right? So I'm going to say this is going to be equivalent from 3 to 7 of a over x plus 1 plus b over x minus 2 dx. Okay, there's our original. We're going to set this equal to this. So we're going to say 1 over x plus 1, x minus 2 equals sum a over x plus 1 plus sum b. So that we're trying to figure out where would this be true. Okay, so here we get a common denominator. Okay, so we get a common denominator. Our process for this part is the same just because it's a definite integral. We just won't have a plus c in our answer, but we still kind of start the process the same way. So once we have that common denominator, you kind of get rid of it, right? Technically you're multiplying, you're cross multiplying and then dividing it out, but these already take up a lot of space on my paper, so I'm just going to go ahead. All right, so we get to here. And then if I had one wish for what a and b were, right, I'm going to kind of figure out what's going on at x equals 2 and figure out what's going on at negative 1. So when I plug in 2, I get 1 equals, that piece zeroes out, and this is 3b, right? So plus 3b. So here b equals 1/3, all right? And at negative 1, I'm going to have 1 equals negative 3a plus 0, and that means that a equals negative 1/3. Okay. So we have this. Now we're going to rewrite the original. So we're basically saying that the original, right? So the original is going to be equivalent to the integral, okay? And I'm going to write it as two of them. So I'm going to say from 3 to 7, and I'm going to do, I'm actually going to do the b part first. So I'm going to say this 1/3 over the x minus 2, okay? And then minus, I'll do plus the integral from 3 to 7 of negative 1/3 over the x plus 1. Oop, and I forgot a dx there, and I need a dx over here. Okay, so there's my setup. So now I'm going to factor out the 1/3 and the negative 1/3 there. And then some of you will kind of get good and you'll kind of do everything in one step. That's fine. So I'm going to say 1/3 the integral from 3 to 7 of 1 over x minus 2 dx. And then I'll do minus 1/3, okay, the integral from 3 to 7 of 1 over x plus 1 dx. And some of you could technically factor out a third, but because a and b are not always the same, I don't always do that. Sometimes I just leave them in there because they're not always the same, so you can't always factor out of the whole thing. So from here, I'm going to say that's going to be 1/3 ln absolute value of x minus 2, okay? And then I'm going to have minus 1/3 ln absolute value of x plus 1. And again, we're going to evaluate this whole thing, okay, from 3 to 7, okay? So this is going to get a little bit long, so let me see if I've got some room. I'm going to scooch all the way over. I'm going to go way over here because I think I'm going to have to write this out a few times. Okay. So when I go from here, okay, so keep in mind that this 1/3 can become an exponent. And a fractional exponent is the same thing as, you can rewrite it using power over root. So you can rewrite it with the cube root. So this is going to be ln, and then I'm going to do the cube root of this divided by the cube root of that. Okay, and then I'm going to evaluate it that way. So I'm going to say this is going to be ln, okay, and then I'm going to do the, you could factor out that, let's do it that way. We'll factor out the 1/3 this way, and then I'll say ln, and it'll be the absolute value of 2x minus 2 thing, and then the x plus 1, okay, and we're going to evaluate that from 3 to 7, okay. So, we'll put it there. Okay, we'll do the 1/3 at the end. So, we've got this. So then I would plug in. So I'll leave that 1/3 for the end. And then I would plug in a 7. So if you plug in a 7 there, you get 5 and then over 8. So it's going to be ln of 5 over 8, okay, minus what you get when you plug in the 3. So that'd be minus ln of 1 over 4. Okay? So then remember, you can kind of use your log properties again to condense this. That's the same thing as the ln of 5/8 divided by 1/4. Well, so that's going to be, let's see if I can fit it in there. So I've still got this 1/3 hanging out, okay? But then I'm going to rewrite it as ln, so that's 5/8 divided by 1/4, which is the same as multiplying by 4. So your final answer could look something like 1/3 ln of 5 over 2. And again, could they then take the cube root of that as well? Sure. So it just would depend on your answer choices there for what that's going to look like. Okay, there could be a variety, but I think that answer is pretty simplified. All right, so I think that's all the partial fractions on the review. I will make a separate video going over some of the improper fractions. So have a great day.